Episode 55 and March 13, 2023. South America, Chile. ROSUP Brief View. A research study from Chile shows that wood burning causes air pollution in Chilean winter in Chilean areas where wood burning is still legal, and other factors such as weather, cause the majority of air pollution in Chilean summer in Chilean areas where residential wood burning is illegal. The authors argue that OP measurement should be used for an air quality indicator that indicates levels harmful to human health, in addition to the PM measurement currently used for AQI, the Air Quality Index, warnings to the public. ROSUP concludes that one air quality management tool could be laws and enforcement of laws against residential wood burning. South America, Chile. ROSUP analysis of the oxidative potential of airborne particulate matter in 2 urban areas of Chile, more than meets the eye. The OP of PM in Santiago and Chillan, Chile argues that 2 scientific measurements, OP and PM, should both be used to more realistically depict the air quality of Chilean cities, and both OP and PM should be used as a template for all cities for the Air Quality Index, AQI. This article proves that in Chillan, Chile, residential human-caused, anthropocentric, seasonable decline in air quality is primarily caused by residential wood burning. Wood burning emits 90% PM2.5 in the winter in Chillan, Chile. This article proves that in Santiago, Chile, summer weather, a meteorological variable of more sunshine, caused decline in air quality, primarily caused by phytochemical interaction of large particulate matter, not primarily PM2.5, with more sunshine in the summer in Santiago, Chile. Wood burning is legal in Chillan, Chile. Wood burning is illegal in Santiago, Chile. The 2 measurements of air quality used for this study are 1. PM, particulate matter, including PM2.5 particulates found in the air of 2.5 micrometer size. Wood smoke is 90% PM2.5, and 2. OP, oxidative potential, which uses one of 2 types of OP measurements. 2A, DTTM, measurement of particulates which measures particulates which happen to be 2/3 PM2.5. The M in DTTM stands for the total particulate mass, and 2B, DTTV, the V in DTTV stands for the total particulate volume. Using both OP, both DTTM and DTTV, and PM will more realistically find if air pollution exists in a city which is at a limit proved by research to be harmful to human health. The measurement OP-DTTM shows that from wood burning in Chillan, Chile in the winter months, in Chile, in the southern hemisphere, winter occurs in May, June, and July, the opposite of the northern hemisphere. There are seasonal high levels of OP using the measurement DTTM in the winter months, where in Chillan, Chile, wood burning is legal and used for heat. In Chillan, Chile wood burning for heat is not illegal. In the second urban area of this study, the capital city of Chile, which is Santiago, wood burning is illegal. In Santiago, the second OP measurement, called DTTV, V stands for the total volume of particulates, is higher in summer. Summer is November, December, and January in Chile's southern hemisphere. The PM measured in Santiago is larger molecules of PM, PM10, of 10 micrometer size. Weather causes higher OP-DTTV when summer sunshine creates greater phytochemical reactions in the atmosphere, and Santiago's PM10 measurements go higher in summer for that reason. In Santiago, wood burning is illegal, so that anthropocentric, human-caused, reason for pollution is not as significant in creating OP and PM pollution in Santiago. Residential wood burning is significant using the measurements for PM2.5 and OP-DTTM in winter in Chillan, Chile. As the study itself concludes, Chillan, Chile is labeled CHI and Santiago, Chile is labeled STG. The spatial, temporal variability of OP can be explained by the emissions that the study cites and the meteorological variables. In Chillan, emissions from wood burning during cold months explains the variability in the DTTM and DTTV values. In STG, Santiago, where wood burning is banned, the increase in PM concentrations is dominated by meteorological variables. Rosup concludes that one air quality management tool could be laws and enforcement of laws against residential wood burning. The oxidative potential of airborne particulate matter in 2 urban areas of Chile more than meets the eye. GLID equals IWER0UGRK20S086INBHDTJ C960FIGI0I23I_0GDC5VU5S7QHDCT and 0. The oxidative potential of airborne particulate matter in 2 urban areas of Chile more than meets the eye. Author links. Open overlay panel. Carolina Molina A, Carlos A. Manzano A. B, Richard Toro A. Manuel A. Leva G. A. https://doi.org/10.1016/j.nvent.2023107866 Get rights and content. Under a Creative Commons license. Open access. Highlights. Seasonality was observed in the estimated OP mass normalized. Higher OP normalized by volume was observed when wood burning emission increased. Air quality index showed a low correlation with the OP mass normalized. Even PM low mass concentration has high OP. Even PM low mass concentration, it may still be harmful to human health. Abstract. Oxidative potential, OP, has gained attention as a parameter that can reveal the ability of different properties of particulate matter, PM, to generate reactive oxygen species, ROS, as one single value. Moreover, OP is also believed to be a predictor of toxicity, and hence the health effects of PM. This study evaluated the OP of PM10, PM2.5, and PM1.0 samples using dithiothiol assays in 2 cities of Chile, Santiago and Chillan. The results showed that the OP was different between cities, PM size fractions, and seasons. Additionally, OP was strongly correlated with certain metals and meteorological variables. Higher mass normalized OP was observed during cold periods in Chillan and warm periods in Santiago, and was associated with PM2.5 and PM1. On the other hand, volume normalized OP was higher during winter in both cities and for PM10. Additionally, we compared the OP values to the Air Quality Index (AQI) scale and found cases of days that were classified as having good air quality, supposed to be less harmful to health, showing extremely high OP values that were similar to those on days that were classified as unhealthy. Based on these results, we suggest using the OP as a complementary measure to the PM mass concentration because it includes important new information related to PM properties and compositions that could help improve current air quality management tools. 4. Conclusions. We present the first full-year study of aerosol OP in 2 Chilean cities for 3 different PM fractions, PM10, PM2.5, and PM1.0, which has been previously studied in only a few studies, and its relation to the chemical properties of PM and meteorological variables. The spatial, temporal variability of OP can be explained by the emissions at the study sites and the meteorological variables. In Chile, emissions from wood burning during cold months explains the variability in the DTTM and DTTV values. In STG, where wood burning is banned, the increase in PM concentrations is dominated by meteorological variables. Thus, higher DTTV values were measured in winter, controlled by the reduced dispersion of pollutants. DTTM was higher in summer when the concentration of ozone and radiation increased at the sites. Those changes were also observed in the PM fractions, with PM1.0 and PM2.5 showing higher DTTM values than did PM10 and no differences in DTTV in Chile even when larger particles were at higher mass concentrations.